Yeah, so we're talking about volume today. So volume, we started with length, right? Length, and then we went to area. Now we're gonna do volume, okay? Volume. All right, if you go to page 212, what do they say about volume? Nothing really important here. On table 7.5, they talk about the oxygen consumption, okay, and that is carbon dioxide production. So this is, I think they're talking about the in a in space. Is this what we're talking about? Okay, just the actual consumption and the production, I guess. Rate of breathing. So as the rate of breathing gets faster, okay, if the rate of breathing gets faster, your oxygen consumption gets higher, obviously, right? Okay. And also, subsequently, the carbon dioxide production goes up also, right? So I don't know if you guys ever seen the movie Apollo 13. They talk about in Apollo 13, they talk about the carbon dioxide levels going up and how that affects them and that kind of stuff. All right. Okay, so one of the things that they talk about when we're talking about volume is they talk about the buoyancy force here. The buoyancy force is the force that pushes something up to the surface, right? Buoyant, so it lifts it up, all right? The reason why it's not that, they only bring this up only because has something to do with the volume, okay? So there's a typo in your book. It says rho V, and this is what your book writes, okay? So this G down here is not a subscript. It's actually a G as in the gravitational constant, okay? So it's rho VG. Your book writes it as though it's a subscript. It is not, okay? Rho is the density. V is the volume, and then you have the 32 feet per second squared, okay? Or the 9.81 meters squared, right? Okay, either one, right? Okay, so that's that. It's kind of makes sense if you think about it. If the rho is the density, right? So this is the density. This is the density of the fluid that is surrounding the object, right? So you have an object here underneath some sort of fluid here, right? You have some sort of fluid here. So the density here is the density of this guy, not the density of the object itself, but the density of the fluid, right? The more dense the fluid is, the more it wants to push it out, right? The more it wants to repel it, the more it wants to go up. It makes it go up, right? So the higher the density, the stronger the buoyancy force, okay? Volume, obviously, the larger or the bigger, the more volume that the object has, the more force, right? Okay. So what kind of things uses the buoyancy force? Does anybody know? If anybody has an example of where we use the buoyancy force in engineering?
Submarines.
What?
Submarines.
Submarines. So submarines work how? How do submarines work?
I think they take on water inside of them to make them heavier, and then they go down.
Okay, so when what we call a dive, when it's ready to do a dive, right? When you do a dive, you have what is called ballast tanks that surrounds the submarine, right? You have ballast tanks. So if you look at a cross section of a submarine, you're going to have tanks along this side right here, okay? Right? So these tanks are where you fill the water or you fill it with air, and that controls how much weight you have, right? So basically you would take on water into the ballast tanks, and then you would dive down, right? You're gonna go down, right? So when you're ready to come back up, you would actually blow pressurized air through the ballast tanks, relieve the water. Now you're much lighter and you will rise to the surface, right? Okay. All right. All right, so that's that. Volume calculations, let's go to page 214. In 214, it has the various volume units and increasing capacity orders. So you start from 1 millimeter, a teaspoon, a tablespoon, fluid ounce, cup, pint, quart, gallon, right? A liter there, right? You have a liter too. And then you have cubic feet and cubic meter. Okay. On page 215, there are some geometric shapes that you're going to use that we know how to do. So there's a cylinder, right circular cone, there's a section of a cone, and then there's a sphere. So as an engineer, you know how to you should be able to spit out the first, second, and fourth one, right? The third one, you would probably look it up, all right? So the first one is the cylinder. These are things that you did in geometry. So you should know how to do these. You have R and you have H, and the volume is equal to what? What's the volume equal to? Pi R squared is the base area times the height, okay? If you had a cone with R and you had H, then the volume is going to be equal to this guy here, pi R squared H, times the magic number 1/3, right? You have to divide it by 1/3. Okay, and then there's the sphere. The volume of a sphere is equal to 4/3 pi R cubed. Okay, all right. Blah, blah, blah. Okay. All right, we're good. Any questions on that? Any questions on the volume there? I mean, it's kind of stuff you already know. There's nothing really earth-shattering here. Okay, there are no questions. I'm going to go ahead and start on the homework.